this video, I am going to describe how we can use matrix norms to describe the condition of a system. First of all, let us start with an example, and this is a very simple example. We have already done this example. 1, 2, 2, this is your A, x equal to B, 2, 3.999, x, y, 4, 7. And we know the solution of this equation is x equal to 2 and y equal to 1. This is your vector x. So the norm of, first of all, let us try with infinity norm. So infinity norm of the solution vector x. Now x equal to 2 and 1, this is a solution vector, is given by norm of x with suffix infinity, and this is equal to 2. How we have got this 2? This is maximization, because the row maximization of maximum of the sum of absolute row. Okay. Now here row only one element is there, in 2 rows. Okay. So maximum, there is no question of summing up, maximum 2, 1. So this is equal to 2. Similarly, if I consider the b vector 4.7.9, and this is the element of b vector. So I can take the norm of b. Again, if you are using infinity norm, we are going to use infinity norm for all the finding out norm of all vectors. Okay. So norm of b vector is b, again infinity, and this will be 7.999, because 2 elements 4 and 7.999 both are positive, highest is maximum is 7.999. Okay. Now if I perturb b slightly to see the conditioning, b slightly as before, so we get our new system of equation as this, perturbing b 4.001 to 7.998. And we know this solution already, we have discussed the solution, x equal to minus 3.999 and 4. Okay. Now what is the change? The new change in b and b vector and change in x the solution x. Okay. If I consider the new change in b, that is the b dash, this is your b dash and this is your b. So minus b dash minus b gives you 4.001 minus 4 equal to 0.001, and similarly 7.998 minus 7.999 equal to minus 0.001. Okay. And what is the change? Change in the solution vector, this is your new solution and the original solution is 2. So you get minus 3.999 minus 2 equal to minus 5.9. So x dash, this is your new solution, original solution, you get minus 5.999 and 3.000. Now what will be your, I am describing these changes as delta x and delta b. So delta b is, this is also actually a vector delta b. Okay. Now what will be the norm of delta b? Delta b infinity is again maximum between these two, positive, maximum between the absolute value of these two. So maximum between 0.001 and 0.001, this will be 0.001, and delta x, norm of delta x will be, this is again in infinity, is the maximum between the absolute value. So positive value 5.999 and 3.000, maximum value is 5.999. So this is the norm of the difference of or change in x. Okay. Now what is the relative change in the norm of x? Relative change can be written as norm of delta x divided by norm of x with respect to x. Okay. So 5.999, this is 5.999, x, norm of x is 2, so divide by 2 is 2.9995. Okay. Similarly, relative changes in b is norm of delta b divided by norm of b. So you get 0.001, this is 0.001 divided by 7.999. So you get a value like this, you get value, the change in the, now if I consider the change of the solution vector with respect to the change in b, because we are going to see how the solution vector is affected by the change of slight changes in b. So that can be written as by the ratio is change of x with respect to change of b. So the value I am putting is 2.995 divided by 1.250 into 10 to the power minus 4, and this value is become 23,993. Okay. Sorry, 23,993. Okay. So this value is very, very huge. The change in the solution vector with respect to the change in b is very huge. Now that is the reason why the system is said to be ill conditioned. But in place of b, here we are considering changes in b, we can use the changes in a also. Okay. Then this this value will be norm of A divided by norm of change in A and norm of A, and this will be the changes in A. And again if you do this one, again you will see that this will be very, very huge. Okay. You can check this problem by doing yourself. So, this is what is called ill conditioning. Now, with this norm, it leads to the definition of a condition number. What is condition number? Condition number of a matrix A of the system of equation Ax equal to B in terms of matrix norm is given by this condition A, norm of A multiplied by norm of A inverse. Now, this norm can be infinity norm, this norm can be absolute norm, or this norm can be Euclidean norm. So, depending upon whatever norm you are asked to find out, so this norm will be given like this. Okay. So, this is the product of norm of A and norm of A inverse. So, condition number A is a constant value, and if it is very, very large, then the system of equation is said to be ill conditioned. So, we will do some problem in the next class.